Now, after doing the first 3 sets of properties, let's now continue with the next set of properties, which says that tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. Note that here there is a very important constraint which is associated with it, that is xy is less than 1. In case xy is greater than 1, then it takes another shape, that is tan inverse x minus x plus tan inverse y will be equal to pi plus tan inverse x plus y over 1 minus xy, and here we have xy should be greater than 1 and both x and y should be greater than 0. The next result is tan inverse x minus tan inverse y is equal to tan inverse x minus y over 1 plus xy, and the constraint for this is xy should be greater than minus 1. Now, let's start doing the proof of these results to see that see the logic behind keeping them. Now, the proof of first result, as we have been proceeding in the same in our earlier proofs, we proceed the same way. Let's start with the left hand side. In this, we assume both of them to be something and then proceed further. So, let tan inverse x equal to theta and tan inverse y equal to phi. Let's call it equation number 1. So, this gives us x is equal to tan theta and y is equal to tan phi. Now, we know from our previous knowledge that tan of theta plus phi is equal to tan theta plus tan phi over 1 minus tan theta tan phi. Substituting the values of tan theta and tan phi from here, we get x plus y over 1 minus xy. Let's call it 2. Taking this to the other side, we get theta plus phi is equal to tan inverse x plus y over 1 minus xy. Now, substituting the values of theta and phi from 1, we get, so 1 gives us, in place of tan theta we will write tan inverse in place of theta we will write tan inverse x, in place of phi we will write tan inverse y, and hence we get tan inverse x plus tan inverse y is equal to tan inverse x plus y over 1 minus xy. It's a very important result. This, along with the constraint, this is valid when x, the product of the two angles x and y, is less than 1. Now, let us consider what happens when x y is greater than 1. We can write, and another thing is that both x and y should be greater than 0. Then what we do is, in place of, we can replace this tan inverse x with cot inverse 1 upon x, and tan inverse y can be replaced with cot inverse 1 upon y. We have already done these results in the previous sets of properties. So, we know that it can be written in this manner. So, now let us take what we get. Now, clearly we can write tan inverse x plus tan inverse y is equal to cot inverse 1 upon x plus cot inverse 1 upon y. This gives us, now in place of cot inverse x, now we have also done the property that the sum of tan inverse and cot inverse of the same angle is equal to pi by 2. So, I can write cot inverse of some angle as pi by 2 minus tan inverse of the same angle. Same way here also I can write pi by 2 minus tan inverse of 1 by y. This gives us pi by 2 plus pi by 2 is pi, and both the negatives can be taken common, and we will be left with tan inverse 1 upon x plus tan inverse 1 upon y. Now, here we will apply the previous result, because since both x and y are greater than 0, we have started with that constraint that x and y are both greater than 0. So, clearly 1 upon x and 1 upon y will also be greater than 0. So, we can use the it can be applied, the previous property can be applied. So, this will be equal to minus tan inverse 1 upon x plus 1 upon y minus 1 upon x into 1 upon y. This gives us, we keep solving, it gives us tan inverse y plus x over xy over xy minus 1 over xy. We can cancel this xy with this xy, and we get pi minus tan inverse y plus x can be written as x plus y, and this is upon xy minus 1. Taking this minus common, we can write it as pi minus tan inverse x plus y over 1 minus xy. Now, we have a result that tan inverse negative of an angle is minus tan inverse that angle, and this gives us pi minus minus of tan inverse x plus y over 1 minus xy, and this gives us pi plus tan inverse x plus y over 1 minus xy, and thus we get the result as, in case tan xy is greater than 1, then tan inverse x plus tan inverse y can be written as pi plus tan inverse x plus y over 1 minus xy. X greater than 0, y greater than 0. Similarly, we can do the next result, and it can be easily proved that if we have tan inverse x minus tan inverse y, we can write it as tan inverse x minus y over 1 plus xy. We proceed exactly in the same way as we proceeded earlier. We will assume tan inverse x to be theta, tan inverse y to be phi, and then use the result for tan theta minus phi. So, tan theta minus phi would be tan theta minus tan phi over 1 plus tan theta tan phi. Replacing and substituting the values, we get this result. So, this is the next set of results. Thank you.